Okay, hello physical science. We're going to wrap up section 2 really quickly here, a really short video, more about covalent bonding. Again, we talked about what makes maybe a bond polar versus nonpolar, and then what can make a molecule as a whole polar versus nonpolar. So what we're going to do today is just wrap up talking about how polar and nonpolar molecules are attracted to one another, and how maybe some are attracted more strongly and some have a little more weak attraction. So now we're just going to look at, and again, attractions are just going to be what holds different molecules together and what pulls them to maybe want to attract to another molecule. So we're going to look at how do attractions between polar molecules compare to attractions between nonpolar molecules. So attractions between polar molecules are stronger than attractions between nonpolar molecules. So I'd definitely write this down. This is going to be on your quiz. Then attractions between polar molecules are stronger than attractions between nonpolar molecules. So again, the ones that have if you have a partial negative or partial positive charge, hopefully that maybe makes a little bit sense as to why you might have stronger forces of attraction. Because if you're just neutral, like a nonpolar molecule is, then you're going to be pretty happy. You're not going to really even need to form a bond with any other molecule. But if you have a slightly positive or slightly negative charge, that means you're going to be a little more likely to want to go out and form a bond maybe between something else that's a little slightly negative or slightly positive. So for our examples, that in a molecular compound there are forces of attraction between molecules. These attractions are not as strong as chemical bonds, but they are strong enough to hold molecules together in a liquid or solid. So water molecules are similar in mass to methane molecules, yet methane will boil at negative 166.5 degrees Celsius and water boils at 100 degrees Celsius. And that's because the methane molecules are nonpolar and water molecules are polar. So that just those slight differences right there result in different forces of attraction and much different physical properties there of when the water will actually boil. And how we can represent our different charges here is actually by dashed lines. So dashed lines represent attractions between partially positive hydrogen atoms and partially negative oxygen atoms. And the symbols, and this symbol right here is actually a lowercase Greek symbol. It's known as delta. So I would make sure, that's definitely going to be a quiz question. I'm going to ask you what the name of this actual symbol is, and I don't think it actually says anywhere on here, but if you're listening, you should know that that is a delta symbol. So an S, or delta minus and delta plus, are used to indicate a partial charge. So right here we can see that there's a partially negative charge in this water molecule right here, or in this oxygen atom within the water molecule, and each one of these hydrogens, again, the electrons spend less time near them, so they're going to have a partially positive charge. So within water, again, and then water is a liquid at room temperature, they are going to have these attractions between the molecules between these positively or partially negative and partially positive portions of the molecule, and that's what's going to hold them together to give them their structure. So these dashed lines are showing that right here this hydrogen atom is attracted to this oxygen atom right here. Same with this hydrogen atom to this oxygen atom, same with this hydrogen atom to this oxygen, and this hydrogen to this oxygen. Just because these don't have the symbols written in there doesn't mean that they don't still have the partial positive and partial negative charges. And attractions among nonpolar molecules are weaker than attractions among polar molecules, but they do exist. Attractions among nonpolar molecules explain why CO2 can exist as dry ice and why nitrogen can be stored as a liquid at low temperatures and high pressures. So that is kind of wrapping it up for our covalent bonds. Again, we'll go over more of what these attractions actually mean in class. But that is actually it for section 2. Let me know if you have any questions.